All right, so we are live right now. I hope I'm audible to all of you. Okay, so welcome back. So I welcome all of you to this amazing platform, Tutee Learning. So in today's class, we're going to continue our discussion on circles, right? So we'll start to discuss about circles, and as of the discussion in the last class, we have so far completed our discussion on the concepts of the points regarding the point in a circle and the line in a circle, right? So we have derived the following consideration that what happens when a line becomes a tangent, or when a line is a chord of a circle, right? Or when the line lies exactly outside the particular circle, right? So we have come across this particular formula, right? And I mentioned that this is the condition for tangency, which we'll be using in our particular discussion of today's class, right? And basis of this, we'll try to write down the equation of tangent, right? So that is what we'll try to do today in our discussion, right? So we are going to start with discussion on the topic of equation of a tangent to a circle at a given point, right? So that is what we'll do, and also we'll try to learn about the notations that we use to denote the tangent to a particular circle, right? So I hope this particular class is going to help you a lot, especially in preparing for your JEE Mains examination. Okay, so please take a note of this particular class because it's going to be very important and crucial. So I welcome all of you to this amazing learner Tutee Learning, and let us get started with discussion on the equations of tangent to a circle at a given point, right? So as we have seen in the last class that we have derived this particular expression, that what happens when a given line, the line equation was mx plus c, when this line is basically a tangent for a circle, we have derived that the condition, the circle was basically given as x square plus y square is equal to a square, right? This was the equation of circle. Now this particular line is a tangent to the circle. This particular line is a tangent to the circle if and only if we saw that my value of a should be equals to mod of c divided by square root of m square plus 1. That is what we have seen in our last class, right? Now in today's class, we are going to, now from here what I can write is that then I can easily formulate the equation of the tangent. So from here I can write down the equation of the tangent to the circle can be given as, by replacing this value of a or c. So this equation of tangent can be given as mx plus or minus a times square root of ms square plus c plus 1, right? Where m is the slope of the tangent, right? Where m is the slope of the tangent. So this is my equation for the tangent, where m is the slope of the tangent, right? Where m is the slope of the tangent. Is this part clear? Right. So this is how we can write down the equation of tangent to a given circle whose center is basically at 0, 0 and the radius is given as a, right? So radius is a, then we can write down the equation of the tangent of the circle of a given form, of a given slope, right? So that is called as a slope format. Okay, the slope form of line. Okay, so this is called as a equation of tangent in the slope form, the slope form of the tangent equation, right? So that is what we have easily derived from here, right? Now if I ask you this question, that let us say that now I'm interested to know what happens if I want to find out at a given point. Now this is basically, we have derived the equation of a tangent of a circle whose center is at 0, 0 and the radius is a. So we have derived the equation of the tangent of a given slope m. Now what happens if I want to ask you what is the tangent, what is the equation of tangent to the circle? Let us say this is my circle with the center as O, and if I want to know what is the tangent to the circle at a given point, let us say that particular point given to us is P, and let us call that point P as x1, y1, which is lying on the circle. So if I want to know or to find out this particular equation of this tangent, now before I discuss about tangent, I want to just quickly brush up about the basic part. Is that now if I draw if I take up any point Q, let us say it is x2, y2, which is again lying on the circle, and we try to draw a straight line joining P and Q, then this will become a chord of a circle, right? So what if I take this chord, so this is my chord of the circle. So what if I take this point Q and I try to bring it as close as possible to that of point P? So if I keep on bringing the point Q as close as possible and then I merge it with point P, then that particular chord at the limiting state, so in the limit when the Q will tends towards point P, so when my Q will tend to point P, this is basically the symbol for tends to. So when my Q point tends to point P, then that particular PQ chord becomes the tangent, right? So therefore, then this particular chord actually becomes a tangent. So that is what we define as a tangent at a given point. Right, so this is basically about the basics part of the tangent, right? And I'm pretty sure that you must have already understood this particular definition in your junior classes, but still it's just a recap. Now, our main discussion from here is to find out how am I going to form the equation of the tangent for a given point. And with this particular thing, we're going to start with a discussion on what is called as a point form of equation of tangent, right? Or with this, we're going to start with point form. Okay, so point form of equation of tangent, let us try to understand this. Now, the plot of the problem is very similar. Just let us write down the general equation circle where the center is minus g comma minus f. So, if I write down the general equation of circle, which is basically of this particular format. So, this is the general equation of the circle, right? So, this is my general equation circle where the center is at the center. The center is basically at minus g comma minus f. And the radius of the circle is basically given as square root of g square plus f square minus of c, right? This is my radius of the given circle, right? So this is the radius, right? So we know about this particular condition. Now what is more important to understand is that we know that if I drop a perpendicular, or if I just drop the radius like this OP line is definitely going to be perpendicular with this tangent at P. Let us call this PT is a tangent, right? So from here what I can write is that OP is perpendicular to PT. I can definitely write like this, right? Because from the properties that the radius is perpendicular tangent at the given point, right? So from here, what I'm going to do is that I'm going to first of all formulate for the slope of PQ, oh sorry, OP, right? Slope of OP line, and that can be given as, so that is y1 plus f divided by x1 plus g. This is the slope of the line OP. Let us call this PMOP, right? Now similarly, if I try to find out slope of the line PT, so let us take up any general point on this PT line as x comma y, and then I can write down the equation of the slope of the tangent, or the slope of the tangent would be equal to minus of 1 upon slope of OP, and that would be equal to this y minus y1 divided by x minus x1, right? So from here I can easily substitute this value back. So from here I can easily substitute the value back to get to the slope form, right? This will basically give me the result in slope form, right? However, now if you recall from your application of derivative that we have already studied that the tangent at a given point is definitely of the slope of the tangent at a given point is nothing but the derivative of that particular curve at that particular point, right? So when we differentiate that particular curve and we try to substitute for the value of that particular point, we obtain the slope of the curve at a slope of the tangent at that particular point, right? So if I differentiate the equation of the circle, what I'm going to get? So I'm going to get 2x plus 2y. So I'm differentiating with respect to x. So it will be dy upon dx, and then I will have 2g plus 2 times of f dy upon dx would be equal to 0. Right, now slope of the tangent for this particular curve can also be given as by dy by dx, right? So if I just find out dy by dx of this curve, it is going to come out something as, so this is going to come out as, and we have to put the value because we are finding at x1 y1, and this particular value is going to come out as x1 plus of g divided by y1 plus of f and minus of it, and this is very obvious, which we've already seen from here, right? So this negative inverse of slope of OP will definitely give you this particular result, right? So this particular result is the same. So what we can also obtain by a differential approach as well, right? Now from here, if I just substitute for this equation, let us try to substitute. So this equation y minus y1 will be equals to this particular slope, that is x1 plus g divided by y1 plus f, and negative times of it, and x minus x1, right? So this is my equation of the tangent. This is the equation of the tangent. Okay, so this is going to be the equation of the tangent, right? Now, if I just solve or simplify this algebra, I'm going to get the equation of tangent to come out something as x1 plus y1 plus g times of x plus x1 plus f times of y plus, what I will get is f times of y plus y1 plus c would be equals to 0. Would be equals to 0. Why? Because this particular part will be coming out as x1 square plus y1 square plus 2gx1 plus 2fy1 plus c, which is equal to 0, because that is the equation of the circle, because x1 y1 is lying on the circle, right? So this is going to come out as something like this. Now this is called as the equation of tangent. This is the equation of the tangent for the given circle at a point x1 y1, right? Now since x1 y1 is a point which is lying on the circle, and this is how we can write the tangent, right? Now what I'm going to explain you is that we can also simplify this notation, and we can write in a shorthand notation that is called as t equals to 0. Now this notation is very important, because not only in circles, we are going to use it throughout our entire conic section. So for any case we get to write down the equation of a tangent at a given point x1 y1, we will just directly call for that conic section the equation of tangent at point x1 y1 is equals to t equals 0. T equals 0. Now what is t? This particular expression over here is basically called as t, right? So how do we get this t expression? Is very simple. So you have to learn some few transformation for it, right? Now what are the transformation that you need to learn for writing down a t? This is very simple as follows. Wherever you see x square, just replace it with x1. Wherever you see y square, just replace it with y1. Right. Similarly, wherever you see x, you just replace it with x plus x1 by 2. Wherever you see y, you just replace it with y plus y1 by 2. Okay. And wherever you see the cross multiply times like x and y, now this particular thing I will basically discuss, especially in hyperbola. Okay. So maybe let us not discuss about this particular part for the time being. I will definitely going to discuss what happens when I have the time like xy, then how the transformation becomes, right? Because this is going to come up only in the case of rectangular hyperbola. Okay, so for the time being we can understand this particular transformation, and so wherever you see this particular x square in the equation of the curve, you just transform with x1. Wherever you see x and y, you just transform with this particular form. Okay, and this is going to give you the result for the t equal to 0, right? Is this part clear to all of you? Is this part clear? Is this part clear? Just let me know in the live chat. Is this clear or not? Anu, hello. Is this clear to all of you? Yes, Anu, I have replied. Okay, so this is how we can formulate for the equation of a tangent to a circle, or what is called as a point form of equation of tangent, right? I hope this is clear. Now we already know the parametric point, or any point on a line can also be, or circle can be given in terms of parameter, that is a, or let us call it r, because we know the radius is r. So that can be given as r cos theta time comma r sin theta, right? So from here also, by knowing the point, I can write down the equation of a tangent to the circle in the parametric form. So by knowing the point, I can write down the equation of the circle, or tangent, sorry, and that is called as a parametric form of tangent, right? So this is basically called as the parameter. Okay, parametric form where the parameter is theta. Okay, where the parameter is theta, so I can write down the equation as x cos theta plus y sin theta. So x cos theta plus y sin theta. Now if I have the center as 0 comma 0, then that is going to equal to a, right? Or maybe the radius r, right? If my center is at 0 comma 0. Okay, so I'm writing over here center at 0, 0. Otherwise, you have to just do the same transformation. That is going to be x plus uh, r cos theta by 2 and then y plus r sin theta by 2. Like you can do it, right? We have already discussed about the transformation, right? So for a given center at 0, 0 for a parametric theta, then I can easily write the equation of a tangent in this particular form. I hope this is clear to all of you. Now from here, one can also derive and come back to the expression of the slope form of a equation of a tangent, right? So from here, one can definitely find out the slope form of equation of tangent, right? Is this part clear? Is this part clear to all of you? Is this part clear? Do let me know in the live chat if you have any questions, any queries. Okay, I can take up your doubts and maybe we can discuss about it. All right, so I hope it is clear now, right? So with this particular part, we can now move towards understanding or what happens when we are writing the equation of a tangent to a circle in the slope form, right? So from here, what happens if I have any general equation of circle like x square plus y square plus 2gx plus 2fy plus c equals to 0. Now what happens if I have this general equation of circle? Now from this general equation of circle, I can also write the equation of a tangent in the slope form, and that would be equals to, so because I know the center is now at minus f, so that equation will be y plus f is equals to x plus g times the slope of the tangent plus, so here we will have plus or minus the radius, which is basically square root of g square plus f square minus of c times square root of 1 plus m square, right? 1 plus m square. So this is what the modified equation of the tangent at the slope form for any random circle with a center minus g comma minus f. So this is called as the slope form of the tangent, right? Okay, is this part clear? Is this part clear? So I hope this part is clear, and with this we are now ready to discuss about what happens if I give you not a point on the given circle to find out tangent, whereas I just give you a point of contact on the chord, right? Or what is called as a point of contact, right? Let us try to understand this particular scenario. So instead of giving you to write the equation of tangent for a given point in a circle, if I give you a circle, so if I give you a circle with a center, let us say 0 comma 0, and the radius is given as a, right? The equation of circle is given as x square plus y square is equals to a square, right? This is the equation of circle, right? And if I want to write out the equation of this tangent of a given slope, that can be written as y equals mx plus a times square root of ms square plus 1, and please note that this is a plus or minus sign, because for a given slope I can have two tangents, right? So for a given slope I can have tangent like this, I can also have a tangent like this, right? So for a given slope, this slope for m, for a given slope I can have two tangents, and that particular two tangents is accounted for this plus or minus sign. Okay, is this part clear? Now we have to understand that how we can find out that if I know the slope form of the tangent, am I always going to solve for the line and the circle to find out this point of contact? So if I want to know this particular point of contact, how am I going to do that, right? So from this equation of tangent to this particular circle, if I want to know the point of contact, I can easily solve either this circle equation, I can with the tangent equation to get to the point of contact P. If you do that, it will turn out to something like am divided by square root of m square plus 1 comma minus plus a divided by square root of m plus 1, right? M square plus 1. This is going to be the point of contact, right? So it is not always necessary to always solve it. Rather, you can remember this particular point of contact to get to the point where the tangent is intersecting the circle, right? Now what happens if I have the circle which is centered at minus g comma f? The only thing that will change over here is that instead of writing the point of contact for x comma y, you have to just replace it with x plus g and y plus f, and that is the only change that you need to do, right? So please take care of this particular change, that when your circle is not having the center as 0, 0, rather minus g, minus f, then the transformation can be simply handled, right? I hope this is clear to all of you. Is this part clear? Is this part clear? Right. Okay, so I'm going through a live chat, and I am pretty sure it is clear to all of you, right? So there is no comments. So I think it is clear for all of you. So let's now try to move on to understand about what happens if I want to draw a tangent from a point which is lying outside the circle, right? So if I have a circle, let us say we have a circle like this, whose center is given as, or let us say the center of the circle is, sorry, the center of the circle is 0, 0, and I want to draw a tangent to the circle from a point which is lying outside, let us say point P, which is x1, y1, right? So for the circle, let us say the circle equation looks something like ax square plus y square is equal to a square. This is my circle equation. And I want to draw a tangent to this particular circle from a point outside the circle. Let us say from this particular point P, right? From this particular point P, we want to draw the tangent to the circle, and let us call this point P where it is intersecting the circle, right? And let us call the center O. So we can easily formulate and also find out the length of the tangent that I'm going to do. So in order to write out the equation of the tangent of the circle from a point which is outside the circle, if I want to write down the equation of PT, I can again apply the same principle and I can get to the equation, right? So maybe if I write down the tangent form of the slope form of the tangent, then the equation of tangent can be written as y equals to mx plus a square root of ms square plus 1, right? This is my equation of the tangent in the slope format, right? Now, since this particular line must pass through this point x1, y1, then I will obtain another equation, that is mx y1 is equal to mx1 plus a times of square root of m square plus 1, right? So if I have this equation, and also I can simplify this equation, I can write an equation that is y1 minus mx1 whole square of it is going to be equals to a square multiplied with 1 plus m square, a square multiplied with 1 plus m square, right? Now from here I can get a quadratic in m which I can solve for. So the quadratic in m would look like m square is times x1 square minus a square minus of 2m x1 y1 plus y1 square minus a square is equal to 0. This part is equals to 0, right? So this is what we will have a quadratic in m. Now solving this particular quadratic in m, we can obtain the two such values of slopes which can be possible. So therefore what I can also tell from here is that from a given exterior point, two sets of tangents is possible to a given circle, right? Two sets of tangent is possible from a given circle. So following for this value of m, depending upon how many values of m we will get, we can comment and write down the equation of a tangent to a circle from a point which is lying outside the circle. Okay, I hope this is clear to all of you. I hope this is clear to all of you. Is this part clear? Is this part clear? Please do let me know if this part is clear or not. Okay, now we can explore this particular idea to find out also the angle that we have over here, because once we know about all these particular properties, we can also find out the distance of this tangent and all such things, right? Maybe in the next class, we're also going to discuss about what is a shorthand notation for writing down this equation of a tangent from a point outside it, right? And also there is a shorthand notation to find out this length of the tangent, that is PT distance, right? Okay, so all these things we need to do, but before that, let us quickly solve one problem. Okay, let us quickly solve one problem to understand this particular concept, right? What happens if you have this? So Now, interesting part over here is that you don't need to actually solve the quadratic, right? You don't need to actually solve the quadratic to get to the two values of m, because we'll try to understand on this question. So you have to find out the angle between the two tangents that can be drawn from the origin to this given circle, right? So what you must be wondering is that we have to again solve for this quadratic equation in M and get the two slopes of the tangents m1 and m2, and only when I know the two slopes then I can solve for the angle between the lines. However, it is not true. In order to find out the angle between two lines, what do we need? So if we recall the formula, that is tan theta is equals to m1 minus m2 divided by 1 plus m1 m2, right? Mod of 1, and this like this, right? So what I can also do is that this 1 m1 minus m2 I can write it as square root of m1 plus m2 whole square minus 4 times of m1 m2 whole divided by 1 plus m1 plus m2, right? Now if you recall from the understanding of the roots of a quadratic equation, now if I say that this is my quadratic equation from where I will get m1 and m2 whose roots are m1 and m2, so by using the properties of the roots, what I can write? I can write m1 plus m2 will be equals to 2 times of x1 y1 divided by x1 square minus a square. Similar manner, we can write m1 m2 will be equals to y1 square minus a square divided by x1 square minus a square. So once we know the value of m1 plus m2 and m1 m2, we don't need to actually solve for m1 m2, right? So without even solving for m1 m2, we can just plug in these values over here. And solve for this particular expression. Now once we solve for the expression, we can easily obtain the value of theta. So that is the best example that we can try to solve by this particular question. So please try to solve this problem. If you solve this problem by on your own, you will be able to answer the angle, and also you will be able to understand that we don't need to actually solve for this entire quadratic, and still we can get to the angle between two tangents. So please solve this question. I have already explained you the hint. I'm directly going to tell you the answer. So please try to solve it before I declare the answer. Okay. Hi Mohit, to whom you are teaching, no one is heat. No one is heat. What do you mean, Mohit? See, the best part of this particular lecture is that it is a live lecture, and along with the live lecture, this lecture will be recorded on the YouTube, right? So it is not like I'm teaching for no one. I am already teaching out for the entire mass that is basically present on the YouTube, right? So anyone who want to study, they can search on YouTube. They can definitely search and get this content, right? So it is the person has not only to be present in the live class, right? Might be an issue that the person is basically now busy with their own life, so maybe they are not able to attend the class live, but this recorded videos are also going to be present, right? So for those people, this recorded lecture is going to help them, right? So it is not like whom I'm teaching for the entire mass, okay? Not only for student from India, but a student from all over the world can connect and maybe study from these lectures, right? Whoever interested to know about coordinate geometry. I hope I'm able to answer your question, Mohit. But you should be not worried about this particular concept. Rather, you should be worried about what is going to happen with you if you are not going to get any rank in JEE Mains examination. Maybe then you have to come back crying, think of which college you will take an admission to, right? That is also now my concern. Anyways, so try to solve it, okay? Try to solve this problem. Please try to solve this problem. Okay, so I'm waiting for any of your answers. Anyone? Anyone with the answer? It's a very simple answer. It's very easy. So I'm still waiting. Okay, so all right, I don't think that you have solved it or not, but it's a very interesting answer, and you will get when you solve for this circle and the point with the given formulation. So let us consider the equation of the tangent to this particular circle in the slope form. That will be y minus 1 is equals to m times x minus 7 plus m plus r times, where r is basically 5 times of square root of m square plus 1. Now if I just substitute origin, because it is passing through the origin, this tangent is passing through the origin, so then I will get the form like minus 1 m minus of m 7m plus 5 times of square root of m square plus 1. So from here, if I just simplify, so 7m minus 1 whole square is going to be equal to 25 times of m square plus 1, right? So if you solve this, you will get a quadratic, and if you just observe the value of this m1, m2 as the two roots, the product of the root, that is going to be minus of 1. So if we have the product of the root to be minus of 1, then the angle between the two lines is definitely going to be pi upon 2, right? So the part, so these two tangents, so the angle between tangents from the origin drawn to the circle is going to be perpendicular tangents, okay? So the tangent is going to have an angle of pi by 2. I hope you're able to get to this answer. Is this part clear? Are you all able to get to this answer? Do let me know. Okay, so I hope I was able to explain you the concept of how to find out the equation of the tangent to a given circle in the point form, and also we found out how we can solve for the point of contact. Also we solved that what happens if I'm drawing a tangent from a point which is external to the circle, right? So with this, I would like to give some homework problems. Maybe you can try to solve this out on your own, right? So please try to solve this problem and do let me know the answer in the comments, okay, comment section. So this is your homework problem. So please try to solve this problem and do comment on whatever answer you're getting. Okay, I'll be waiting for your answers in the comment section of this particular video after this live is ended, right? So I hope this discussion is clear in today's class. So today we were able to discuss about the equation of a tangent, right? Now in the following class, we are going to move into understanding about the length of a tangent from a given point, and also we are going to continue our discussion with chord of contact and a pair of tangent, right? So those are the two important concepts that we need to understand along with the formulation of this equation of tangent, right? So there are also shorthand notation to also remember those particular thing, and with that we're going to move into writing the equation of normal, right? We are also going to move into writing the equation of a normal for a given circle, and with that we will be soon moving forward towards general topic, and then we will be going towards family of circle, and with that you can think that your circles is also going to be finished. So maybe another 4 or 5 lectures and I'm going to definitely finish off the circles, right? So with that, we're going to start with parabola, and ellipse and hyperbola are soon to be followed for that, right? So maybe you can take this particular note that by the end of this month, November, we'll be finishing with our portion of coordinate geometry, right? And also from 26th of November, we are going to start with our one-shot revision lectures on this particular channel itself. And till then, I hope you have enjoyed watching this particular content, and please keep on watching this content, because this so please be disciplined enough so and study this particular content, because whatever you're studying, whatever question we are discussing, that is definitely going to be the base for your JEE Mains preparation. So please do that, and also keep on solving these homework problems, okay, because that is also going to help you a lot in understanding the basic concepts, right? So with this, I thank you for your wonderful attention in this lecture, and I hope to